All right, so we've created some enhanced input actions and an input mapping context. We need to use these input actions, and we're going to set things up in the player controller class. You can do this in the character class as well, but I find that things are a little bit more organized keeping input in the player controller class, so that's my personal preference for this project. So in our Crash Course game module in the public folder, here in Writer, I'm going to go to Add Unreal Class and choose Player Controller. It's right here under Common Classes, and I'm going to put this in its own folder called Player. So we'll keep things like Player Controller and Player State here in the Player folder. And I'm going to prefix it with CC, so it'll be CC Player Controller. We'll go ahead and create this class. Now for this player controller class, we're going to have an override for setup input component. This is where we're going to set up our inputs. That's going to be in the protected section. So we'll say virtual void setup input component. We'll go ahead and override this function. And here is where we're going to add our input mapping context. So we're going to have a variable for the input mapping context. For now, I'm going to close our character class files and just have our new player controller here. And I'm going to make a private section for our member variables. And the input mapping context is going to be stored in an array of input mapping contexts. And that's because we're going to have multiple input mapping contexts. In this project, we're just going to have 2. And this allows us to avoid having to put all of our input actions in the same input mapping context. And we can also swap them out at runtime if we wanted to. So I'm going to have a T array. And the T array is going to contain T object pointers, each of which have the type U input mapping context. So I'm going to call this input mapping contexts, plural. And in order to use this type without including it here in the header file, I can forward declare the class uInputMappingContext at the top. And we're going to be filling in this T array in the player controller blueprint that we're going to create. So it's going to get uProperty, and we can give it edit defaults only in order to be able to set that. And we'll go ahead and give it a category, and as we expose variables to the details panel, I'm going to start putting our variables in the category of crash with a subcategory, and that way we can always just search for crash to find all of our different crash course variables that we create for the project. So it'll be crash pipe symbol input, no spaces there, very important. And along with our input mapping context, I'm going to have an input action for each of our input actions, jump, move, and look. So just under input mapping contexts, I'm going to create a T object pointer of type uInputAction. And this one is going to be jump action. We'll start with jump, and it's going to get a uProperty, edit defaults only. And we'll put this in the same category crash pipe symbol input, so it'll be there along with the mapping context. And we can go ahead and forward declare this class as well, uInputAction, to get rid of the red. And of course, we're going to have 2 more input actions. We're going to have one for move and one for look. So we have move action, and copying it again, we'll have look action. And we're going to bind callback functions to these 3 input actions in setup input component. For that reason, I'm going to create those callback functions here, also in the private section. These are internal to the player controller. So there'll be void functions. The first will be jump, and jump isn't going to need any inputs. I'm also going to create a stop jumping that we'll bind for when we stop pressing that jump action. And then we'll have move and look. So I'm going to have void move, but this one will get a input parameter, and it'll be a const reference of type f input action value. And this allows us to get the value in those inputs. I'm going to call it value. And this being a reference means that we can forward declare this struct as well. We just have to use the struct keyword. So we'll have struct f input action value here. And we'll have one more callback. This one will be for look. I'm simply going to call it look. And now we have 4 callbacks. 2 are going to be bound to the jump action, and move will be bound to move action, and look to look action. We'll go ahead and generate the definitions for these functions. And for now, I'm going to leave them blank, and we're going to set things up in setup input component here. So the way to do this, if you haven't already, this being a more intermediate course, I expect that you've done this before, but we first need to get the enhanced input local player subsystem. And we can do this by creating a local U enhanced input local player subsystem pointer. I'm just going to call it input subsystem. And we can access it through the static function on U local player called get subsystem, which is a template function. We need to specify the type of subsystem we want to get. That's the enhanced input local player subsystem. And this function requires a local player, which we can call get local player for and pass that in. Now, we can't forward declare here, right? We have to include the header file. And it looks like I have a typo here. I'm going to fix that. And the include for this would be an enhanced input subsystems.h. And now that I have the input subsystem with a quick isValid check on it, if isValid input subsystem, we can use this to add the mapping contexts. Now, we created a T array of input mapping contexts, and I want to add all of them. So I'm going to go ahead and use a for loop for that. I'm going to say for U input mapping context in input mapping contexts. And here, for each one, I'm going to take the input subsystem and call add mapping context. And we can pass in the context itself, and we can pass in a priority, and I'm going to give them all a priority of 0. Now, a couple comments on matters of style. One of the things you could do if you wanted to is take the input subsystem local variable, and you could put it inside the if statement with the semicolon there, and it'll check the isValid check. We'll not get into the if statement if isValid fails there, and that's one less line of code. That's one way to do it. Another way is you can simply take your local variable and declare it here. It'll exist outside the scope of the if statement, and you can perform an inverse isValid check here. You can say if not isValid input subsystem, and then you can return early. This allows you to minimize the number of nesting statements that you have, and then you could just have your for loop here, and you don't have a double nested statement, and I personally prefer that. I don't like to nest too much, so this is the style that I would normally use. Just keep in mind that if you have an early return here, you'll never reach anything farther in the function past this early return if it fails. So just keep that in mind. That's an important thing to note. But regardless, once we've added these mapping contexts, all of them that are in the array, we can now use the input actions in them, provided that we bind callbacks to them. So that's what we're going to do next. To do that, we have to get our input component and cast it to an enhanced input component. So we say U enhanced input component. I'm just going to call it enhanced input component. And we're going to cast to U enhanced input component the value of our input component, which we have access to from here in the player controller. And enhanced input component is in enhanced input component .h. And we can perform a quick isValid check here as well. So we can say if not isValid, enhanced input component return. And now we have our enhanced input component, which we can use to bind our callbacks. So we'll start with jump. We'll say enhanced input component. We're going to call bind action, passing in our jump action, which we have here. And for jump, I'm going to use trigger event started. So we'll only trigger it once as soon as the input is pressed. Next, we need a uObject. We're going to use this because our callback is on this class, and the function will be at this class jump. You can also use ACC player controller here, but this class is synonymous with that. And we're also going to bind to the same jump action, except instead of started, we're going to use completed, and instead of jump, we're going to use stop jumping. Now we can bind to the others similarly, but for move and look, we're not going to use started, we're going to use triggered, so that we trigger our callback every frame that the input is being pressed. So I'm going to copy the line for jump and change it to move action, and change it from started to triggered, and change the callback to move. And we'll go ahead and copy that line, and we'll have look action, triggered, and the function will be look. So this binds those callbacks. We need to actually program the functionality inside of them. And for jump, we can simply get the character that our player controller possesses. Get character is a function on the player controller class, and it just returns the character if it's possessing one. Now, depending on when this function is called, we need to make sure that it's valid, because if it's not, we'll try to dereference a null pointer. So we'll just say if not is valid, get character, return. Now I can simply click on the red squiggles, Alt-Enter from here in Writer to include GameFramework/character.h, and we should get it up there at the top. So if the character is valid, we can access the character through getCharacter, and we can call jump, which is a function on the character class. That's why I use getCharacter and not getPawn. And stop jumping will be quite similar. We're going to copy these lines and paste them into stop jumping, except we're going to call stop jumping, of course. So those two input actions are pretty easy. Move has an F input action value, as does look, and we're going to use those to program our movement. Now, we could call getCharacter here, but for move and look, we actually only need the pawn, so we can call getPawn. It's not a big deal if you call getCharacter, but we only need the pawn. So we'll check to see if getPawn is a valid pointer, and then we'll get our movement vector from the input action value. Now for move, this is the WASD keys. We're going to have two axes, X and Y, and we can get those and store them in an F vector 2D. So we can say const F vector 2D movement vector. And what we do is we take our value, we call get on that value, and get on F input action value is a template getter function. We can specify F vector 2D here. And now we know that the X is our left and right movement, A and D, and our Y is our forward and backward movement, W and S. Now the way that I want to apply this vector to move our character is first to find which way is forward. So we're going to say find which way is forward. And what direction is forward? Well, I'm going to use the control rotation because our camera is going to follow our controller's rotation as we move the mouse. And whatever direction we're facing camera-wise, I'm going to consider that to be forward. So I'm going to make a const F rotator called yaw rotation because I only care about the yaw component of my control rotation. So I can initialize yaw rotation by calling the F rotator constructor here, and I can simply pass in 0 for the pitch and the yaw from my controller's rotation. So I can call get control rotation dot yaw, and then I can pass in 0 for the roll. So the middle one here is the yaw, at least in C++. Confusingly, it's the Z component in Blueprint in the details panel, but that's beside the point. We now have the yaw rotation, which is just the control rotation with its pitch and roll zeroed out. And from this yaw rotation, I want two vectors, the forward direction corresponding to yaw rotation and the right direction. So we can get those and store them in local F vectors. They'll be const, and I'm going to call the first one forward direction. And it's going to be obtained by using an F rotation matrix. So I'm going to make an F rotation matrix out of yaw rotation, which is just a mathematical construct that has its own member functions like get unit axis, we can get a unit vector from a rotation matrix constructed from a rotator, which is just a vector with a length of 1 in the direction we specify. And forward in Unreal Engine is the x-axis. Now, some of you might have the question, if forward is x in Unreal Engine, then why is forward in our value the y-axis? Why isn't it the x-axis? Well, that's just how we set it up in the input mapping context. You could have set it up differently if you wanted to, but this is the more common way because a two-dimensional system typically considers x to be left and right and y to be up and down. And in a three-dimensional system, at least in Unreal Engine, x is forward, y is right. So to get our right direction, we can make a const f vector called right direction. We can use f rotation matrix with yaw rotation, and we can call get unit axis specifying the y. That will give us the right vector. And then we simply need to get the pawn and call add movement input, first passing in the forward direction, passing in our movement vectors y, and then we can call add movement input passing in the right direction with our movement vectors x. So again, I know it seems confusing that we're getting the unit axis x for the forward direction corresponding to yaw rotation, but then from our input action value, we're using the y. Again, that's just how we set it up in the input mapping context, based on which keys out of WSAD we assigned to the y and x, using our swizzle and negate modifiers. But I won't dwell on this for too long, as this should all be review for you. So we have move. We're also going to program our look callback. And for look, we just want our look vector from the value. So basically, we can create a const f vector 2D. I'm going to call this look axis vector. And look axis vector can be used to simply add yaw and pitch input to our controller directly. We're in the controller, so we have add yaw input. We can use look axis vector.x, and we can use add pitch input with look axis vector.y. And with that, we have all of our callbacks and we've programmed functionality for them. We just need to create a player controller blueprint and assign our input mapping context and our input actions. So we can compile and launch the Unreal Engine editor and set this up in the editor. So from here in the editor, we need to make a blueprint based on our new player controller class. We're going to put that in Crash Course. I'm going to make a new folder here called player, and we'll mimic the structure in our C++ project here in Blueprint. And our player folder will get a new blueprint class, and we're going to search for cc_player controller. We're going to choose that, create that blueprint. We'll call it bpcc player controller. And we're going to open this up and find our crash variables. So I'm going to search for crash here, and here they are. We have our array with no elements in it, but we're going to add an element to our input mapping contexts and choose IMC movement. And then we need to add our jump action. We're going to choose IA jump. For move action, we're going to choose IA move. And for look action, choose IA look. Make sure you don't mix those up. Put the right ones there. And we'll go ahead and compile and save that. And we need to make sure that our game mode is using this player controller. So we'll go to our game folder, open up BP Crash Game Mode, and find the player controller class and choose BPCC player controller, compile, save. And we should be able to press play and click to engage. We have camera control, and we have control over the character. We can move, we can jump, and we have a working character now. And everything's handled in the player controller for inputs here, and we don't have to clutter up the character class to do that. And because input mapping context is an array, we can also create more input mapping contexts. We're going to do that next. It's going to be a challenge for you in the next video. For now, we've got a good setup started. Excellent job, and I'll see you soon.